Let's talk about the unit circle. So what is the unit circle exactly? Well, if this is, say, we have a graph, right? Say we have a graph, and let this be our x-axis, let this be our y-axis. The unit circle is just a circle that's centered at the origin, so 0, 0, and has a radius of 1. So it has a radius of 1. So I'll try my best to draw a circle. So this circle right over here has a radius of 1, meaning that from here to here, right, this part over here is a radius of our circle, and it's a length of 1 unit. So the coordinate over here, this is going to be 1, 0, right? This is a radius of a circle, and since you're going 1 up, the coordinates of this point is going to be 0, 1. And this part is a radius as well, so you're going 1 to the left direction. That's going to have a coordinate. It's going to have a coordinate of -1, 0, and you're going 1 unit down right over here. So this coordinate right over here would be 0, -1. And why is this circle, seemingly useless circle, kind of important? Well, let's kind of review on our trig functions. So a lot of teachers will probably be mentioning this phrase, and it's SOHCAHTOA. And basically, if you have a right triangle, let's say this is a 3, 4, 5 right triangle. And you can use the Pythagorean theorem to test this if this is actually a right triangle. 3 squared plus 4 squared, that's 9 plus 16, equals to 5 squared, which is 25. So SOHCAHTOA is basically used to express ratios between the sides, the length of the sides of a right triangle. For example, sine of an angle represents the side opposite that angle over the hypotenuse. So in this case, right, sine of, let's say, this angle right over here, sine of this angle right over here, right, let's say this is angle theta, this is going to be equal to the side opposite this angle, which is 4, over the hypotenuse, which is 5. Cosine of this angle, cosine of theta is going to be equal to the side adjacent that angle over the hypotenuse. So if this side is opposite this angle, and if this is our hypotenuse, well, then this side has to be our adjacent side. So this side's our adjacent side, so let me just label this actually. This side is opposite this angle, this side is our hypotenuse, and this side is our adjacent side. So cosine of theta, cosine of our angle, is going to be equal to the side adjacent this angle, well, it's this side, which is length of 3, over the hypotenuse, which is 5. And tangent of an angle is going to be equal to the side, tangent of our angle is going to be the side opposite that angle over the adjacent side. So the side opposite that angle, well, that's 4, and the side adjacent to it, it's 5. That's 3. So it's going to be 4 over 3. Now, a lot of the times, right, it seems impossible that you can take something like sine of 135. Basically, what I mean is that whenever you use sine, cosine, tangent, these 3 trig functions, well, you're usually only going to be using them on angles that are less than 90. For example, you can take sine of 45, sine of 60, things like that. But it kind of seems impossible to take sine of 135, because then, right, it's not going to be a right triangle anymore. And these trig functions, right, you can only use sort of these ratios in right triangles. So how can you use them? How can you take sine of 135, right? Seems outright impossible. And that's where this circle comes in handy. So first of all, let's say that this is our base of an angle. So let's make this part the base of our angle. And we're going to draw an angle somewhere in this region. So in this first quadrant. And what we're going to make this our base of an angle, and we're going to draw a ray. Right? We're going to draw a ray. And obviously you can see how when I drew this ray and I'm going to make this the base of our angle, right? Let's say it creates some sort of angle theta, right? Our ray is going to intersect the unit circle at some point. And this point right over here, let's say it has coordinates x comma y. Let's say it has coordinates x comma y. And what I'm going to do is I'm going to draw altitude down. So I'm just going to draw a straight line downwards so that it meets the x-axis. So it intersects this point right over here. Now you can all agree that this point over this part of our triangle that we created, right, this is actually going to be a right triangle. So this part of our right triangle right over here, this side right over here, this represents the x value of our point, right, of this point. So this point has an x value, right, represented by this side, and this point right over here has a y value represented by this side, right? This side represents the y value of our point. So now let's take cosine of the angle that we just created. Cosine of theta. So we create an angle, so that's our first step. We create an angle. We see where the kind of ray intersects the unit circle, and we draw this right triangle. And cosine of this angle right over here, this is going to be equal to the side adjacent this angle. Well, if this is our opposite side, right? This is the side opposite this angle, right? That's going to be y. And this is going to be our hypotenuse, right? So this is going to be our hypotenuse. And this is going to be the side adjacent our angle. And we know cosine of an angle is equal to the side adjacent that angle over the hypotenuse. So it's going to be this adjacent side, which is x, over the hypotenuse. And because this right over here, our hypotenuse is actually a radius of our circle, so it's going to be equal to 1, right? Because the unit circle centered at the origin and has a radius of 1. So this right over here is actually a radius of the circle, which means that cosine of our angle that we just created is going to be equal to the x value right over here over 1, which is just equal to x. And sine of theta, that's going to be equal to, well, that's going to be equal, sine of theta, that's equal to the opposite side, the side opposite that angle over the hypotenuse. So sine of our angle that we just created is equal to the side opposite that angle, which is the y value, over the hypotenuse. Well, we know the hypotenuse is 1 because it's a radius, so it's just going to be equal to y. And you can see how our x value is equal to the cosine of theta, and right, so our x value is equal to cosine of theta, and our sine value and our y value is equal to sine of theta. So we can actually rewrite this coordinate as cosine of theta, comma sine of theta. So basically, if I make any sort of angle in this quadrant right over here, if I make any sort of angle in this region, well, the coordinate where the ray intersects the unit circle, it's going to have a coordinate cosine of theta, cosine of the angle you create, comma sine of theta, sine of the angle that you've created. So we know that if we have an angle, right, we can make an angle in this quadrant right over here, and the point where it intersects the unit circle is going to have the coordinates cosine of theta, comma sine of theta. This isn't really neat, so let me just write it over here. So cosine of theta, comma, sine of theta. So that means that the x-coordinate, which is this length over here, this length represents the x-coordinate of our point. So this length is going to be cosine of theta. And this length right over here, this is going to be sine of theta, right? This is going to be our y value. So this length right over here represents our y value. And our hypotenuse is equal to 1 because it's a radius of our circle. Now, one thing you might be noticing, can you do the Pythagorean theorem with, this thing? And the answer to that is yes. And this is something called the Pythagorean trig identity. And it basically says that this value squared, right, cosine squared theta plus sine squared theta is going to be equal to 1, right? Basically, a squared, which is this side right over here, our x value, plus b squared, well, this is going to be our y value, right? This side squared, equals to the hypotenuse squared, which is just 1. 1 squared is just equal to 1. So, yeah. So this is the Pythagorean trig identity. So basically, let's say that if cosine of theta is equal to 0.74, and let's say that we're trying to find what sine of theta is equal to. What is sine of theta going to be equal to? So it's basically like you're given the x value of our coordinate right over here, but we're trying to solve for the y value. So we just plug it into this formula. So cosine of theta is 0.74, and we're raising that to the second power, right? A squared plus b squared. In this case, b squared is b squared is going to be sine squared of theta, right? A squared plus b squared is going to be equal to 1 squared, or just 1. And when you put this into your calculator, right, first of all, divide both sides by 0.74 squared. Just move this over here. So subtract 0.74 squared on both sides. And we're going to get 1 minus 0.74 squared. So this is going to be sine squared theta is going to be equal to 0.4524. And if you take the square root of it, well, you're just going to get sine of theta is going to be equal to plus or minus square root of 0.4524. And that's going to be your answer. So yeah, that's kind of just how you would do one of these problems. Just take the value, plug it into the Pythagorean trig identity, and you good. Now let's talk about some special kind of values in the unit circle, some special angles. What I mean by that is, let's say that, right, once again, this is our x-axis, this is our y-axis, and what we decide to do is this time we create a 45-degree angle. So like this. So we create a 45-degree angle. Once again, this is the base of our angle. And maybe some of y'all can do this, but I want to find out, what are the coordinates of the point where this ray intersects the unit circle? What is this coordinate going to be? And once again, what we're going to do is you're going to draw just a straight line down to the x-axis, and you want to creates a 90-degree angle. And then immediately, some of y'all might notice that this right triangle we have is a 45, 45, 90 right triangle. And once again, this length right over here is going to be 1, because that's the radius of our circle. So in a 45, 45, 90 right triangle, if you have these two side lengths x, right? These two side lengths are x. Just draw the angles real quick. Okay. So when you have a 45, 45, 90 right triangle, right? The length of the hypotenuse of your right triangle is always going to be radical 2 times longer than your sides, than the other sides of the right triangle. So for example, if I have a right triangle where if I have a 45, 45, 90 right triangle where my hypotenuse is, let's say, 2 radical 2. Well, from this formula, we know that, well, the hypotenuse is always radical 2 times longer than any one of these sides. So to get from 2 radical x radical 2 to x, we'll just divide this by radical 2. So the side lengths are going to be 2 and 2, right? To get from x radical 2, right, all you have to do is just divide by radical 2. And if you divide 2 radical 2 by radical 2, you just get 2 as your 2 side lengths. So in this case, right, our hypotenuse is 1. So all we're going to do is just going to divide 1. We're just going to divide 1 by radical 2, right, to get from x radical 2 back to x. So this side is going to have a length of 1 radical 2, and so is this side, right? Because both of these sides have the same length, as this is also an isosceles triangle. So yeah, this is an isosceles triangle. So the opposite sides of these angles have the same length, meaning that if this side has a length of 1 over radical 2, the other side has the length 1 over radical 2. Right? You see how there's two x's right over there? And if we rationalize the denominator, so we just get rid of this denominator over here, you're actually going to get, right, these square roots are going to cancel out. You're going to get radical 2 over 2 as your x and y coordinates. So basically, the coordinates of our point over here is going to be radical 2 over 2, comma, radical 2 over 2. So when we create a right triangle with a 45-degree angle on the unit circle, the point where this ray intersects the unit circle, the coordinates of that point are going to be radical 2 over 2, comma, radical 2 over 2. Let's talk about another special. Let's do another one of these, right? So let's say if I have a unit circle, and let's say in this case, what we're going to do is we're going to create a 40, not 45, I meant 30-degree angle. Let's say in this case, we create a 30-degree angle. And we want to find out what are the coordinates, what is this coordinate going to be, right, where the ray intersects the unit circle. Well, once again, we can draw an altitude down, which creates a right angle. And you might recognize this right triangle as a 30, 60, 90 right triangle. So let me just draw another diagram. X radical 3. So the hypotenuse of our 30, 60, 90 right triangle, right? The hypotenuse of a 30, 60, 90 right triangle is always going to be 2 times longer than the side opposite the 30-degree angle. So if I have a right triangle, right, where let's say this is 30, 60, 90, once again, and the hypotenuse of our triangle is, let's say, 4, while the side opposite 30 is just going to be 2, right? It's going to be half the length of the hypotenuse. And also, in addition to that, the side opposite 60 is radical 3 times longer than the side opposite 30. So if this side is 2, well then the side opposite 60 will just be 2 radical 3, right? I'm just going to do another example to make sure that y'all are on the same page as me. So let's say if in this case, right, 30, 60, 90, and let's say that our hypotenuse in this case is 4. Wait, no, that was the same one I did. Let's say our hypotenuse is 6 in this case. Well, the side opposite 30 will just be half the length of 6. Well, that's just going to be 3. And the side opposite 60 is just going to be radical times longer than the side opposite 30. So it's just going to be 3 radical 3. And now, right, you'll see that our hypotenuse, I'll just keep this on the page so you can see this for yourself, right? Our hypotenuse is 1, which means the side opposite 30 has to be half of 1, right? The side opposite 30 is always half the length of the hypotenuse. So the side opposite 30 is just going to be 1/2. And the side opposite 60 is always radical 3 times longer than the side opposite 30. So if this is 1/2, well, the side opposite 60 will have a length of radical 3 times, right? 1/2 times radical 3, or radical 3 over 2. So you can see that this side over here has a length of radical 3 over 2, and this side right over here has a length of 1/2. So the coordinates of this point right over here are going to be radical 3 over 2, right? Because that's our x value, that's this value over here, comma 1/2, right? Because 1/2, that's our y value, that's this value right over here. Finally, let's do another one. This is the last special angle you kind of have to memorize. So let's say if I have a unit circle, and this one's going to be really similar to the last one we did, to this one right over here. And what we're going to do is, in this case, we're going to create a 60-degree angle. So right over here, we create a 60-degree angle in this case. And I want to find out the coordinates of this point right over here. So how can I do this? Well, drop an altitude down, right? Drop this line down so that it creates a 90-degree angle. We know this length right over here is going to have a length of 1. So that's a radius of a circle. It's the radius of a circle. And once again, it's another 30, 60, 90 right triangle, right? And we know that the side opposite 30, so the side opposite 30 is always half the length of the hypotenuse, meaning that our hypotenuse is 1, and the side opposite 30 is over here. So this part is going to have a length of 1/2. And we know that the side opposite 60 is always radical 3 times longer than the side opposite 30. So the side opposite 60 is going to have a length of radical 3 over 2. That means that the coordinates of our point is going to be the x value comma the y value. So the x value is going to be 1/2. And the y value is going to be radical 3 over 2. So you can see how, right, the 3 special angles that I talked about, right? If you create a 45-degree angle on the unit circle, the coordinates of this point is going to be radical 2 comma radical 2 over 2 comma radical 2 over 2. If I create a 30-degree angle on the unit circle, the coordinates of this point are going to be radical 3 over 2 comma 1/2. And if I create a 60-degree angle, you'll see how it's just the 30-degree angle, but it's flipped, right? The x and y value swapped. Now let's talk about reference angles. So what exactly is a reference angle? Well, the definition of a reference angle is just the smallest angle that an angle makes with the x-axis. So if we have a 135-degree angle, the the acute angle, right, the reference angle is going to be this angle right over here, right? And this angle, well, we know that if a straight line has an angle of 180 degrees, so if this is 180 degrees, and we're trying to find this angle right over here, well, we know that x plus 135 is going to be, so x plus 135 is going to equal to a straight line, which is 180 degrees. And solving for x, we get x equals 45 degrees. So this 45-degree angle would be the reference angle, right? It's this acute angle that's sort of created with this x-axis, right? This x-axis right over here. Let's do another example. Let's say that if I have an angle like this, and let's say this is a 225-degree angle. So what is the reference angle going to be for this? Well, the reference angle, well, it's going to be this acute angle that's formed with the x-axis. So what you would do is you would actually subtract, right? So we're trying to find this angle right over here, this small angle. The reference angle would be this angle right over here, right? It's this acute angle that's created with the x-axis. So to find this angle, right, what we would do is, well, we know that this part is 180 degrees, right? So let me just do this color. We know that this part right over here is 180 degrees. And we're trying to solve for this part, and we know the whole thing is 225 degrees. Well, what you would do is just subtract 225 by 180. And you would get 45 degrees, right? X would be equal to 45. You see, if the orange region is 180 degrees and the whole thing is 225, well, to solve for this one tiny part, you would just subtract the whole part by the 180 degrees, right? And you would get 45. Well, let's finally do this one. So let's say that I have a reference angle like this, right? Let's say I'm trying to find a reference angle for this angle. Let's say this is a 335-degree angle. 335-degree angle. So it's going to be this angle right over here, this big giant angle. And the reference angle for this would be this angle right over here. It would be this angle right over here, this acute angle that's formed with the x-axis. Let's call this x. And how do we find it? Well, we know the whole circle, right? This whole circle, this whole rotation has a measure of 360 degrees, right? You're going 360 degrees in total. And we know that if this part is 335 degrees, well, we know that 335 degrees plus whatever angle that this is, well, we know that it's going to be equal to 360, right? This part, this whole part, plus this tiny part is going to give us a full 360 rotation, right? 360 rotation. So doing the math, you should get x equals 25 as your answer. So basically, just to sum up how you would do reference angles, right? If you are in the second quadrant, the reference angle would be 180 minus that angle, 180 minus the angle that you create. So, right, in this case, right, we created a 135-degree angle, so the reference angle is going to be 180 minus the angle we created, which is 45. If your angle is in the third quadrant right over here, all you have to do is subtract the angle that you created minus 180, and you get your reference angle. And finally, if your angle is in the fourth quadrant, what you do is you subtract the angle that you created. You subtract 360 minus the angle that you created. So in this case, 360 minus 335, and you get your reference angle, which is this angle right over here. Now let's put everything we learned to the test, and let's try to find cosine of 135, and let's find the value of sine of 135. So let's draw our unit circle. So x, y-axis, and then let's say we have our unit circle here. And when we make a 135 degree angle, right? So right over here, if we use this as the base of our angle, right? A 135 degree angle is going to cross into the second quadrant, right? Because a 90 degree angle is this, right? And a 135 degree angle is bigger. 135 is bigger than 90 degrees. So our angle is going to pass onto the second quadrant. It's going to be in the second quadrant, this region right over here. So we're going to draw this ray, and this ray right over here to make the angle, it's going to intersect this unit circle at some point, right? And now, actually, what we're going to do is just like how if we have an angle, right, in this first quadrant, what we do is we drop an altitude down, right, and create a right triangle. Well, we're going to do the same thing right here, right? So we have this 135 degree angle. And what we're going to do right now is we're going to draw altitude from this point right over here where the ray intersects the unit circle. And we're going to draw an altitude down to the x-axis, right? And this creates a 90 degree angle. So this is just like what we've been doing in the past problems I've shown you. And right over here, right? If this is a 135 degree angle, well, what is this angle going to be? Well, we can see that this is our reference angle, right? This is the reference angle. And if a straight line, right, this straight line has a measure of 180 degrees, and you have this part of this straight line that has a measure of 135 degrees, well, this angle right over here is just going to be 45 degrees, right? Because 45, just erase this. So this angle right over here is going to be 45 degrees, right? Because 45 plus 135 gives us this 180 degree angle. Now you'll notice that once again, the hypotenuse of our right triangle is going to be equal to 1. And this is another 45-45 right triangle, right? And just to recap, when you have a 45-45-90 right triangle, the hypotenuse of your right triangle is always going to be radical 2 times longer than the other two sides. So to get from x radical 2 back to x, just divide 1, our hypotenuse, by radical 2. And that's going to be the length for both of the sides. And if you rationalize it in the denominator, so you just get rid of the radical here by multiplying the top and the bottom of your denominator by radical 2, you're going to get that this value over here is radical 2 over 2, right? Because we know that the length of both of the sides are the same, which means that this side right over here is also radical 2 over 2. All right. So now we know that kind of this right over here is our x coordinate of the right triangle, right? This side over here is the x coordinate of our right triangle. And this right over here is the y coordinate of our right triangle. So the coordinate of this point right over here, well, what's the coordinate of this point? It's going to be x comma y, right? It's going to be the x value comma the y value. In this case, the x value is going to be negative radical 2 over 2. Right, negative radical 2 over 2. Because, right, we're moving backwards in this x direction, right? We're moving to the left, which means that this length right over here is actually negative. This coordinate right over here is actually negative radical 2 over 2, right? Because we're going in this direction. While our y value is just going to be radical 2 over 2, right? Because our y value in this case is still positive, right? Our y value in this case is still positive. It's only the x value in this coordinate that's negative. So if you're in the second quadrant, it's just another thing to know is that if you're in the second quadrant, your x value is negative and your y value is positive. So in this case, right, our x value is radical 2 over 2, y value is the same thing. Well, our x value is going to be negative radical 2 over 2 since we're in the second quadrant. And, the x value is going to be negative radical 2 over 2. And our y value is going to be positive radical 2 over 2 because we are in the second quadrant. And this means that, right, we also know that the coordinates of the point where this ray intersects the unit circle, well, from the beginning of the video, I said that was equal to cosine of theta. In this case, our angle right over here, right, cosine of the angle, well, that's going to be equal to 135 degrees, right? So the coordinates of this point, cosine of 135, comma sine of 135, is also equal to this point, right? The coordinates of this point is cosine of 135, comma sine of 135. And in this case, we found out that cosine, or the x value of our coordinate, is equal to negative radical 2 over 2. So cosine of 135 is equal to negative radical 2 over 2, right? Cosine of this angle is just going to be the x value of the point where this ray intersects the unit circle. Well, sine is the y value, right? Sine, remember, sine was the y value. So that means that sine of 135 is equal to this y value right over here, radical 2 over 2, which is equal to radical 2 over 2. All right. And let's actually do another problem, right? Let's say we want to find cosine, right? Let's say we want to find cosine of, let's say, just 210. And we also want to find sine of 210 degree angle. So what is this going to be equal to? Well, once again, we're going to draw our unit circle, right? And right over here, let's say that this is the base of our angle, right? And what we're going to do is, because this angle is 210 degrees, right? We know that a 180 degree angle is this angle right over here, right? So this is going to be a straight line, right? So a 210 degree angle will actually go all the way into the third quadrant. It will actually be in somewhere over here. So let me just draw the angle real quick. So this is what a 210 degree angle would look like, right? This angle is 210 degrees, and it's past the second quadrant. So now we're in the third quadrant right over here, right? And now what we want to do, right, is you want to, in this case, right, what we've been doing is, right, if we have an angle like this, what we've been doing is we've been drawing an altitude down. In this case, because our angle is in the third quadrant, if your angle is in the third quadrant, what you're going to do is you're going to draw an altitude up. So you're still going to create this 90-degree right triangle, right? You're still going to create a right triangle. So this is still going to be a right triangle. And now, right, our hypotenuse right over here, from this point to this point, is still 1. And right over here, in our right triangle, what you'll notice is that what is this angle right over here? So what is this angle right over here? What do you think this angle is? Well, if this whole thing right over here is 180 degrees, right? So if this angle right over here, if the angle of the straight line of this line right over here is 180 degrees, Well, this tiny segment must be 30 degrees, right? Because 210 is equal to this 180 degree angle plus this mini angle right over here. So this angle right over here is actually 30 degrees. And notice how this is also, right, when we've been doing these problems, right, this angle right over here, we're looking at the reference angle of this giant angle right over here. So that's kind of why, that's why I mentioned it a couple minutes ago, because I knew it would be pretty important, for finding these sort of mini acute angles. So right over here, once again, we got a 30, 60, 90 right triangle. So let's find the values of the sides. We know that in a 30, 60, 90 right triangle, let's just do this one more time. So right over here, we know that the side opposite 30 is always half as long. So wait, hold on. This is going to be 2x. This is going to be x and then x radical 3. So we know that the hypotenuse is always 2 times longer than the side opposite 30. Meaning that if the hypotenuse is 1, well, we know that the side opposite 30 is half as long as 1. What's half of 1? That's just going to be 1/2. So this part of our right triangle is going to be 1/2. And in this case, right, this side right over here, the side opposite 60, we know that's a radical 3 times longer than the side opposite 30, right? So if the side opposite 30 is equal to 1/2, well, the side opposite 60 is radical 3 times longer than the side opposite 30. So this side right over here is just going to have a value of radical 3 over 2, right? Radical 3 times 1/2. That's just radical 3 over 2. So what are the coordinates of this point right over here going to be? Well, we know that our x-coordinate right over here, right? Our x-coordinate is negative radical 3 over 2. And that's because, right, we're going radical 3 over 2 in the negative x direction, right? If you're in the third quadrant right over here and you pick any one of these points on the unit circle, you'll notice how their x value, all of them are negative because you're in the third quadrant. And guess what? In the third quadrant, right, if you're in this region of the unit circle, right, not only is your x value negative, right, you see how if I pick this point right over here, our x value is negative, but so is our y value, right? So basically, right, we know that this right over here, the length of this side is equal to 1/2, and we're going 1/2 down, right? We're going 1/2 downwards. So that means that the coordinate of this point, the y coordinate of this point, is negative 1/2 because you're going 1/2 down. If you're going 1/2 up, it would just be positive 1/2. But since you're going 1/2 down, it's negative 1/2. Right. So the coordinates of this point where the ray intersects the unit circle is going to be negative radical 3 over 2, comma, negative 1/2. So this means that, right, cosine of the angle, of our angle in this case, we know cosine of our angle is equal to the x value of our coordinate. So cosine of 210 is going to be equal to negative radical 3 over 2. So cosine of this angle is going to be equal to the x coordinate of the point where this ray intersects the unit circle, and sine of this angle is going to be equal to the y coordinate of the point where the ray intersects the unit circle. So in this case, sine of 210 degrees is going to be equal to the y value of our coordinate, which is negative 1/2. And boom. Let's do another one. And let's try a pretty big angle this time. So what about let's take I want to do cosine of 300 degrees. And I want to do sine of 300 degrees. What would this look like? What would this look like? Well, we know that, right, if we use this as the base of our angle, we know that this is 90 degrees. We know that this angle right over here is 180 degrees. This is 180 degrees. We know that this angle right over here, this big angle right over here, you can think about it as 3 right angles in a row, right? 3 right angles in a row. And 3 times 95, 3 times 90, that's going to be a 270 degree angle, right? And we're looking for a 300 degree angle, meaning that our angle is going to be somewhere in the 4th quadrant. It's going to be somewhere, it's going to be located somewhere here, right? Because if this is a 270 degree angle and we're going to a 300 degree angle, well, it's going to be someplace like here, for example. So a 300 degree angle would look something like this. This giant angle right over here. 300 degree angle. Right. Yep. And just like the previous problem we did, where like when we had this ray right over here making this angle, we dropped an altitude down, which is exactly what we're going to do right now. Whenever you have an angle that's in the 3rd quadrant or the 4th quadrant, what you want to do is you want to drop an altitude down from the point where this ray intersects the circle. And this is going to create this 90 degree angle. Okay. Now, if this is a 300 degree angle, what is this angle going to be? What is this angle going to be? So let me just do this in a different color. What is this angle going to be? Well, we know that, right, we're making sort of a whole rotation, right? We're kind of going 360 around a circle, right? This whole circle right over here, one rotation is 360 degrees, right? And if this angle right over here is 300 degrees, and if we know that this angle right over here makes a full rotation of 360 degrees, well, we can set up this equation, right? Where we can say that 300 degrees plus this angle right over here is equal to 360 degrees, right? Because you're making one rotation around the unit circle, which is 360 degrees. So this 300 plus x is equal to, so if you actually solve this, x is going to be equal to 60. So this means that this angle right over here is 60 degrees. This angle right over here is 60 degrees. And you see how, once again, this is our reference angle, right? That's why I did the practice problem once again. This is why I did the practice problem before, because this is also another reference angle, right? And you could use like the 360 minus the angle you create formula to kind of solve these problems, to help solve these problems. And once again, 30, 60, 90 right triangle with a hypotenuse of 1. So, once again, I'm assuming y'all know how to do this, but I'm still going to do it anyways. So, we know that the side opposite 30 degrees is going to be half as long as the hypotenuse length. So, the side opposite 30, that's just going to be 1/2. This is going to be 1/2. And the side opposite 60 is always radical 3 times longer than the side opposite 30. So the side opposite 60 is going to be equal to radical 3 over 2. So what are the coordinates of our point? What is the coordinates of this point right over here? Well, you'll see how, right? You'll see how we're the x-coordinate of our point, right? We're going in this direction, right? Our x value in this quadrant is positive, right? If we pick any point from the fourth quadrant, you'll notice how our x value for each and one of them, so you'll notice how if I just pick 3 random points from the fourth quadrant of our unit circle, you'll notice how each one of them has a positive x value, right? Has a positive x coordinate. So this means that the x value of this coordinate right over here is going to be positive 1/2, right? Because we're going 1/2 to the right. Now, we're going down by a factor of radical 3 over 2, meaning that, right, our y value in this case, you'll notice that our y value is negative. So this y coordinate is going to be equal to negative radical 3 over 2. So that means that cosine of 300 degrees, probably should have drawn this further, but you'll notice how cosine of 300 degrees, well, that's going to be equal, cosine of this angle is going to be equal to the x value of this point. So cosine of 300 is going to be equal to 1/2, and sine of 300 is going to be equal to the y value of our point, which is negative radical 3 over 2. And there you have it. Now you know how to take cosine, sine of higher degree, sort of higher angles, right? Angles that are bigger than 90 degrees. And yeah, so just to kind of recap, right? Just to kind of recap what we've done. If your angle is in this quadrant, in the second quadrant, so in this area right over here, you'll notice how our x value is negative, right? If I take this point, you'll notice how our x value is negative, but our y value is positive. And if you look at the coordinates of our point, you'll notice how our x value is negative and our y value is positive. If you have an angle that's in this quadrant right over here, you'll notice how the angle, our x value, is negative, right? If I take a point right over here, you'll notice how the x value is negative and the y value is also negative. So hence why both these have negative signs. And if your angle, where did it go? And if your angle is in the fourth quadrant right over here, your x value is actually positive, but your y value is still negative. So this is positive and this is still negative. So those are kind of the key takeaway points right over here. And it's always important. I recommend drawing a diagram of the unit circle and doing this so that you'll know like what x value is positive or if your y value is negative, depending on which quadrant you're in.